The objective of this lesson is to solve radical equations. We're going to do some of the basic types of radical equations and outline what the steps are for that, and then give several examples. So first of all, the steps for solving radical equations. We start with isolating the radical. Get it all by itself. The next step is to go ahead and check the index, because that is the number that is going to tell us what to do to undo the radical. So that's the number. Put both sides to that power. So for example, that might mean square both sides, or cube both sides, etc. Whatever the index is, put that power to both sides. Next, you're going to solve the equation. That's results, because you won't have any. In this case, in many of the examples we're going to do, like here, you're going to not have a radical left. And in more advanced versions, you might have to go through the process again. And then last of all, you need to check your answers. Now this might be new for many of you, but this is necessary because in essence, step 2, when you square both sides or put something to the fourth power, any even power to both sides, you might create an answer that is incorrect. That's called an extraneous solution. So an extraneous solution is an incorrect solution created in step 2. Now, in essence, this is important. You have to do it when you have an even power that you're putting to both sides. The odd ones, you can, when you're doing an odd power, you actually can do the odd power to both sides and it won't create the extraneous solution. But it's just good form to go ahead and check it to see that you did your work correctly. But I'm going to put here, it's an even index, especially important to do it when you have an even index on your problem. So let's try some examples. Let's start with this one. First step is to get the square root by itself. So I'm going to add 3 to both sides. That gives me 14. Go ahead and square both sides and you get that 14 squared is 196. I'm going to take and divide both sides by 2. I get 98. Now we're going to check that 98 to see if it works. You check it by going back to the original equation. Don't go down here because it will work in some of these other equations. Go back to the original. At least you have to go back before you square both sides. So the square root of 2 times 98 minus 3, does that equal 11? So let's ask that question. The square root of 196 minus 3, does that equal 11? Well, the square root of 196 is 14, minus 3 does equal 11. It checks, so my solution is 98 to this problem. All right, let's try the next one. This one's a cube root, so remember that we are going to check it, but you don't have to in this case. The radical is already by itself, so I'm going to cube both sides. Cubing it will get rid of that cube root, so x plus 1 equals 8. Subtract 1, you get x equal to 7. Let's go ahead and just do a check to make sure we did our steps correctly. So we go back to the original. Is the cube root of 7 plus 1, does that equal 2? Was the cube root of 8 equal to 2? And the answer is yes, it is equal to 2. We'll do the next one's another square root. So we want to get the square root by itself first. So we're going to subtract 2 from both sides first. I get 15 here. Divide both sides by that 5 to get the square root by itself. So the square root of x minus 4 equals 3. Now I'm going to square both sides, and I get x minus 4 equal to 3 squared, which is 9. Add 4 to both sides, you get x equal to 13. Now let's check to see if 13 works. So we'll put it back into the original. 5 times the square root of 13 minus 4 plus 2. Does that equal 17? This is 5 times the square root of 9 plus 2. Does that equal 17? That's 5 times 3 plus 2 equals 17, and it does. That's 15 plus 2 equals 17. So our answer for this one is equal to 13 for our answer to that problem. Okay, and this one, our answer was 7, so we'll put it in solution set form. All right, let's try this last one now. Okay, so we've got the radical to get by itself. We'll subtract 10 from both sides. When you get to this step, this is probably a clue that you're gonna get no solution on it. You can actually stop here because a square root or even any even index cannot equal a negative, not in the real numbers. So when we do that, you've got to make sure that if you spot it here, you can stop and say no solution. We're gonna go ahead through the steps and square both sides. Notice what this does is it creates a positive from that -9 squared. -9 times -9 is positive 81. That's the thing that can add the extraneous solution when you square. This will be just x minus 5. Add 5 to both sides, you get 86. So we want to go ahead and check our answers. So checking this one, I'm going to put it back in the original. So the square root of 86 minus 5 plus 10, does that equal 1? So this is the square root of 81 plus 10, does that equal 1? That's 9 plus 10 is 19, does not equal 1. So those don't equal each other. That means that this is not a solution, so we have no solution to this problem. So when you're solving radical equations, you follow your steps, isolate, solve, go ahead and then check your answers in the final problem. When you do that, you go ahead and you can have situations where you create extraneous solutions like this one, where when you check it, it doesn't work because by squaring both sides, we made a negative into a positive, and that meant that the solution that was created is not a solution to the problem. So follow the steps, solve your equations for radical equations.